Hello and welcome to today's session, ML and Automation Today. What does and doesn't work in the SOC? Cybersecurity teams are looking to mature their security operations to the next level. Automation and machine learning are promising functionalities to scale this day-to-day operation and tasks of a cybersecurity team. I want to showcase you today what is working and what is not working. My name is Matthias. I'm a cybersecurity specialist working for Splunk. I'm a certified ethical hacker, so I know how Nmap scan and API attacks are working, as well as I'm a CISM, so I know what risk acceptance means for an organization. So I want in the next 20 minutes to give you a few key takeaways. First, we quickly look into the mission and challenges in security operations to level set everyone. And then I want to jump with you into machine learning, what mindset approaches are failing and which ones are successful. I will bring and share with you also how success looks like with a specific customer example from a very famous, well-known organization. And then I will also show you the same approach for automation, but that one we will just cover quickly without an example. So cybersecurity operations. To level set, it's a dedicated IT function within an organization that has the responsibility to watch for security anomalies, detect incidents, and take actions to respond to. Often those security operations teams are staffed 24/7 the entire year. Sometimes they're just 8 to 5 and then overnight they're on call, or often organizations are even doing a hybrid approach with a managed service provider, so that half of the security operations team is internal and half of them is external. What are the challenges today? And I work across hundreds of security operations teams in EMEA. Many are Splunk customers, and we capture their success, their progress, their maturity step by step. And what we hear from them is that, for them, it's key that they reduce the dwell time from when they detect an incident, when they how long it takes them to investigate, to respond and to clean up. That times are shrinking, thankfully, in also the surveys we often do, but still way too long for the damage that can be done by an attacker. The other next to cybersecurity problem is that cybersecurity teams have too many tools. They are interacting with the entire IT organization, even not just with Office applications, but also now more and more with the development teams. So they are switching between maybe cloud platform interfaces and configuration interfaces to firewall management systems, SIEM solutions, vulnerability scanning solutions, and more. We have, most of the large organizations have way more than 50 different tools, and the browser tabs are just looking crazy within security operations. Then skill shortage. There are not enough cybersecurity people that you can hire even if you have enough budget, so they are limited. We need to make sure that we use the most efficient, the ones that we have, with on topics they are best on. And then remote work. COVID has shown us digital transformation has happened overnight. A lot of new cloud services, a lot of new office productivity apps have been introduced in organizations and deployed quickly overnight. And the security operations team is tasked to protect it. Just make it secure. They have to learn about new technologies. What might be the risks? What might be the configuration mistakes that are most common to do? And this really keeps all the cybersecurity teams up at night. So at Splunk, we're a leading cybersecurity firm. Our vision is of a modern security operations, and that's what we help organizations with, is that the tier one analyst work, 90% of that work can be automated. And machine learning also counts into automation. Then those people, the people in the security operations center get 50% more time back, where they can learn about new tools or systems that organization introduces and how to protect them best and put automation back on the protection side. And all of that ideally in one platform. I agree, we might still never get to that point with one platform. That's the ideal state. However, reducing 50 browser tabs to only a handful is also very helpful already. So I want to start with machine learning first, and I often present machine learning technologies to cybersecurity teams, and it's really interesting to see what they think it is, and then if we are seeing other companies going through the process of implementing, operationalizing it, gaining value through machine learning, we see the reality. But before we go into those myths, I want to also level set you not just on security operation, but also on machine learning. So on machine learning, it's no magic. Machine learning is maths and statistics. Always keep that in mind. Often I see some other myths where people think it's magic. It's definitely not magic. One important thing is the data you send in. If that's garbage, it's a useless prediction. If you throw more data through an algorithm with in a bad data quality, it won't get better. You will receive false statements. And also keep in mind, 80% from the normal data scientist, right, is data preparation. Managing data, collecting data, adding context to the data. And machine learning and AI, and that is the most important thing I want you to take away from today's session, and I will repeat that multiple times, is you need to understand the fundamental business problem you want to solve. And that fundamental business problem is not cybersecurity, I want to detect any kind of attack. No. That goes down to what specific attack in what specific environment in what specific situation. But more on that if we do the success check. So there are different levels of machine learning and skills needed. So there is the domain expertise in cybersecurity or IT, or if you do society analysis, right? So there is the domain expertise, or with COVID, we have seen it, all the science environment where they are doing those KPIs and statistics and calculations, right? So you need to be a domain expert. Then we have the data science experts who are really good in maths, building models, and then you need data experts, right, who are able to provide the right data and so on. And we at Splunk, we are a leader in machine learning and data platforms. So we try to bridge all of that, right? So there are finished SIEM tools with machine learning built into, where you don't need to have any expertise of machine learning. You just need cybersecurity expertise and how to get the right data in. And on the other side, we have things like deep learning toolkits, as well as machine learning toolkits, where with drag and drop, you can, for example, get into that level and play a little bit around. We have many cybersecurity experts who want to jump into the field of machine learning and do a little bit on their own. That's a perfect hybrid mix. So, number one myth that we often hear, and that's really interesting, is rule-based detections are no longer working and machine learning is the only way forward in today's threat landscape. That's wrong. If you have privileged users, domain admins, who are logged on locally with their high privileged user, on the laptop and are surfing maybe through their home and not through the company proxy server and gateway in the internet, there you don't need a machine learning tool to tell you that that is dangerous. So the reality is that security hygiene comes first, and then you can optimize it through machine learning. That's a journey. And rules are still very, very accurate and do work. Machine learning is automating and improving all that logics and detections to the next level. You can't skip it, unfortunately. The next myth. Machine learning is implemented in hours and works out of the box universally in the environment. You just put it in, you put some data forward, and then it's running. Or you install an agent, and then it's collecting, and the magic is happening. That's unfortunately not the case. Data quality is key. And you need to collect the right data, you need to understand the use cases, and then from there, the models are working, the models can be built up, the models are trained potentially, and then you can consume that. If you miss a specific data point that the machine learning model demands, it's not working. So data quality is key. And last but not least, we no longer need to maintain a strategy for detecting cybersecurity threats. That's often if organizations are starting with SIEM first and they say, oh, all those rules, use cases, I don't want to think about all of that. MITRE ATT&CK, right? MITRE ATT&CK matrix. I don't want to talk about that. I just want to install something and that should solve it. And unfortunately, you need to have, as an information security person, you have the responsibility to ask and to know what that machine learning tool that you're purchasing is doing. How do those models work? What is the data points that they're collecting? What kind of attacks do they detect? How do they detect it differently than other things? And then you can identify what might be missing and what is still working. What is still maybe a white space in your environment, you need another tool or another protection mechanism. There is no way there is one solution that covers everything. Just keep that in mind. You don't need to understand the math. You don't need to understand how to write a machine learning model and how to maybe edit it, right? So that's something you don't need to know, but you need to understand how it works. So let's go into a reality check. So what does success look like? I want to give you an example. So here is the perfect example on a scientific method where you understand the fundamental business problem. You remember? One thing, understand the business problem you're trying to solve. So the problem might be that ransomware and so on, they are using domain generated or domains that are generated by algorithms and then registered, and then they are used as command and control URLs. And there is an infinity number of domains, so you can't block those proactively on your proxy data or internet gateway. So this means, how would you detect that? So the hypothesis is that with machine learning, you can train an algorithm or develop an algorithm that the algorithm is detecting those dynamically generated domains because they look quite strange for a human, right? There are some examples. And a rule does not work for that. This is something where really machine learning that thinks like a human, that observes like a human, and that model would work really, really well. But to make sure that this is working, this model needs data from your internet surfing activity, either from the endpoint, you have an agent on it, or from your internet gateway, all your traffic goes through internet traffic gateway with the URL in, so that this URL is then basically analyzed, and the features, how long is it, how many different letters are in and so on, is all analyzed and putting into that algorithm. And then you can do benchmarking. So you can take a sample data set, and we have also that our data scientists, and they are benchmarking them. So you can see here, for example, on the new domain analysis, right? So you can see a domain that's a domain generated algorithm, and the prediction was also DGA. And here, for example, you see that one is a legit domain tagged as legit in the sample data set, but it was wrong classified. The others are all correct. You see also eTravel, legit domain, was predicted as a legit domain, right? So this is an example where machine learning works really, really well. And then you can create an action to disable that machine, isolate that machine before encrypt the network drive proactively, right? So these are then all options you can do to work faster through machine learning. Here is an example from one of our customers, Siemens, worldwide known in their high secure data center. In 2018, Oliver presented that they started basically within the SOC to mature into those journeys, into that journey I'm talking about. And Oliver explained that when he's in the playground with his kids, he's telling that he's fighting the cyber, in the cyberspace, the cyber attackers. But in reality, what he's doing in his company is that he is doing security hygiene jobs. So what is security hygiene? Privileged user definition, privileged user monitoring, establishing, adding context, but also things like time synchronization between systems. And think about your environment. Do you know if the time synchronization is working and everyone is at the same clock? It might be the simple things that sometimes are needed to fix first. And a year later, he developed different machine learning use cases on anomaly detection, on predictive analytics, as well as clustering, from user account protecting privileged user accounts to identifying system compromises or malicious proxy communication. So with one machine learning rule, for example, they are analyzing 20 million command line executions on their systems every day. Just imagine that, if they are malicious or not. That's again something that a machine learning rule works really well, and a rule is not working so well about that. Imagine how many users or security analysts they would need to do that, or they just wouldn't deploy such a solution. Another topic is if it's built into. That's, for example, in the Splunk Security Information Event Management tool, where we have a defined set of data sources, and if there is one missing or two missing, maybe half of the data models are not working, right? So remember, data quality is key. And then we have that machine learning engine, where the models, over 60 models that our data scientists with security background, they're rare people, have developed, programmatized, benchmarked, so they are as good as possible working in every environment. They're learning, they're creating anomaly signals, and then we have a second tier machine learning where all the alerts and anomalies are synchronized or put back into, are connected together in a graph, for example, and then we present a full storyline of a potential attack that is now worth to investigate. So again, machine learning for detection. And now we quickly jump super speedy into the automation space. So in automation, often the security orchestration, automation response tools are doing this. So the myth is that the tool that you purchase will define the standard operating procedures, what you should automate. That's wrong. The tool will help and come with out-of-the-box playbooks, but you still need to define what you want to automate. Then The myth is that you will automate an entire standard operating procedure end to end, and then you do the next one, right? So that a full job, a full use case is automated. And in fact, that's not the case. Organizations are starting to automate existing subtasks more and more. And then as they mature, they connect those together. So that individual steps like checking an IP address against 5 threat intel databases or uploading a malicious file to 5 different tools, right? These individual steps are done, created and automated, and then you connect them to a larger playbook together. And then number 3, with automation, we will execute preventative actions such as a user block or IP block. You can do that, but you don't start with that. Often you start with adding more information so you can make that decision for a block, for an isolation of a system, for taking down a data center or an individual digital service. So this will be done from the tool, but the journey starts with the human in the loop. So you just review and then you click approved or not, and then the block is happening. Okay, so I hope that session was interesting for you. Feel free to reach out to us. You can find me on LinkedIn as well. And the lesson learned, machine learning and automation is a journey. Data quality is key.